Hey everyone, welcome back to my channel EduVibe. Today we will start with the another topic of the forces and fields, which is electrostatic force, and we will also doing the Coulomb's law. As you all know that Coulomb is the SI unit of the charge, which is Coulomb, which we denoted by C. So there is one Coulomb's law we have to cover in this, which is related to the electrostatic force. So what is electrostatic force and what is that equation for the formula for the Coulomb's law? Let's find it out in today's lesson. So firstly, how can we make that Coulomb's law equation? So for this, we have to know some terminology. So electrostatic force is proportional to the product of the charges interacting. So in that case, in electrostatic force, we have two charges. We name them charge 1 and charge 2. As so in the previous lesson, we will do by the two charges. The direct contact when we do a conduction, so it will do with the two charges. So that two charges we considered in the electrostatic force now. So they mentioned that they are proportional. So electrostatic force denoted by Fe, and this is the vector. So and this is proportional to the Q1 and Q2, which are the product of two charges as they mentioned. After that, the electrostatic force is a inverse scale law with respect to the distance between the charges. So now another thing we have to there that the distance between the charges are the reverse of scale. What means the reverse of scale? Means the reciprocal, like Fe is now again proportional to the reverse of the distance between the charges. So the distance between the charges are denoted by r, and this is a square, so we do the 1 upon r square. And also I have to mention over there, when we made the graph of this, if we get any graph of related to Fe and r, this is the inversely proportional, so that's why there's like this type of graph when we made that type of graph. So this graph is very important in this. So when we do the relationship between the electrostatic force, charge and distance, we get one formula over there, which is Fe, which is electrostatic force, proportional to Q1 Q2 upon R square. So this formula we get, but this proportional sign has to be not be there. This has to be is equal to sign. To make the is equal to sign, and when we all know that when we remove the proportionality sign, we will get one constant value. That constant value in that case, when we plug in that constant value, we will get the Coulomb's law. So we will remove that proportionality sign to is equal to, and we get the k over there, k constant, which is like made that formula like this. So this is the Coulomb's law. Fe is equal to k q1 q2 upon r square. So this means Coulomb's law allows us to determine the magnitude of the electrostatic force between the charged objects. So we have two charged objects, and the force between them is called the Coulomb's law. So let's do like Fe is the magnitude of the electrostatic force, the force which is due to by the charges, and this is denoted by the Newton. The Q1 and Q2 are the magnitude of the 2-point charges, which are in coulombs. That r square is the distance between the 2-point charges in meters, and the k is again the constant value, and we have that constant value called the Coulomb's constant. So this also value given in your data sheet, which is 8.99 into 10 raised to power 9 Newton dot meter square per Coulomb square. So this is the value you have to know in the constant term, and this formula is also on the data sheet. So don't worry to memorize this. Don't worry to memorize the constant value. This all are on data sheet. So we have an example on this now. So we have an example to cover in this. So this is all related to electrostatic force. So we have a two identical metal surface which has charge of negative 5.0 to 10 raised to minus 6 coulombs and 2.8 into 10 raised to power minus 5 coulombs are briefly touched together and then separated by a distance of 6.0 meters. Determine the magnitude of the electrostatic force between them. We do the example. So that's why it's a simple example guide. We have to know that how can we use that formula. But you get the more complex one questions in that. We will do that practice in practice questions when we do. So in that case, we have Q. So always you have two charges over there. That two charges has to be one charge. So we have to find that one. So you have to find one with Q. So if it is Q1, this is Q2. So you have to add them both. So negative 5.0 into 10 raised to power 6 minus 6 coulombs. Add by 2.8 into 10 raised to minus 5 coulombs. And we have to get the average type of thing. So you all know that when we have two charges, we have to add them both, find the Q, and after that we have to divide this by 2. So why we have to divide this by 2? Because that two charges that after that they separated. After they are separated by a distance of 6.0 meters. So that's why we have to divide this by 2. So when we divide this by 2, we get about 1.15 into 10 raised to power negative 5 coulombs. So this is your Q, and you have formulated this in this that Q1 and Q2 are both equal to this. So if they both are equal to this, so when we do Q1 is equal to Q2, so this means we do Q square in this. So instead of writing that Q1, Q2, we get Q square, which is the same thing. So we want the electrostatic force. So we know that K is 8.9 into 10 raised to power 9 Newton dot meter square, C square, and we have 1.15 into 10 raised to power minus 5. This is coulombs, and we have R square of 6.0 meter square. We get the meter square cancel, 1 coulomb we got this coulombs, and when we calculate this, we get about 0.033 newtons. So this is the magnitude of the electrostatic force between that two charges. So that's how you can find that Q, and when you find that Q and Q1 and Q1 as a Q, you get the electrostatic force between them. So that's how this formula works in questions. We do the more complex question practice question when we do. So for today's, this is for you that how can we use this, not need to memorize this formula. So this is all for this lesson. This is a short lesson. We just know about the electrostatic force and the Coulomb's law. So learning made simple with EduVibe. Learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. In the next lesson, we'll do some vector analysis. Then we will move on to the practice questions of this part. So see you in the next lesson. Till then, stay connected with EduVibe.